Section 10.2, Rational Exponents. All right, so we'll start with the definition of a to the 1 over n power. Just remember that the numerator is your power and the denominator is your root. So we can write this as the nth root of a. For example, if I have 4 to the 1/2 power, that is the same as the square root of 4, which is 2. Or 8 to the 1/3 power, that is the same as the cube root of 8, which equals 2. Or 16 to the 1/4 power, that is the 4th root of 16, and that equals 2. All right, so we want to evaluate each exponential. The first one is 64 to the 1/3 power. I can rewrite this as the cube root of 64, and I know the cube root of 64 is 4. 100 to the 1/2 power is the same as the square root of 100, and that equals 10. All right, negative 256 to the 1/4 power. Just remember that the exponent only applies to what's immediately in front of it, so it only applies to the 256 and not the negative. So I'm going to write the negative outside of my 4th root symbol. And of course I would carry that negative over into the answer, and if I multiply 4 times itself 4 times, I get 256, so negative 4. All right, now if I have negative 256 in parentheses and I write that to the 1/4 power, that means that the exponent applies to that whole quantity. So that would be the 4th root of negative 256. And remember that whenever your root is even and you have a negative under the radical, that's going to lead to a non-real number. So this is non-real. All right, negative 32 to the 1/5 power, that's the 5th root of negative 32. Now this one I can evaluate because my root is odd. So if you have an odd root with a negative under your radical, that you can do. And that is going to equal a negative 2. All right, and then 1/8 to the 1/3 power. You can rewrite that as the cube root of 1/8, which you could separate and make it the cube root of 1 over the cube root of 8, and that would be 1/2. All right, so again, basically the same definition. The meaning of a to the m over n. Just remember that your numerator is your power and your denominator is your root. So just think about where are higher powers. Up high, numerator. Where do you find roots? Down below, that's your denominator. So a to the m over n, I can write that as the nth root of a to the m power. All right, so we want to evaluate each exponential. The first one is 36 to the 3/2 power. that means that we're going to take the square root of 36 and then raise that to the third power. So the square root of 36 is 6, and then 6 raised to the third power. 6 times 6 times 6 is 216. All right, 125 to the 2/3 power. All right, that means we're going to take the cube root of 125 and then take that value and square it. So the cube root of 125 is 5, and 5 squared is 25. Okay, -4 to the 5/2 power. Remember that rational exponent only applies to what's immediately in front of it. So I'm going to leave that negative out front and then take the square root of 4, and then I'm going to take that and raise it to the 5th power. So the square root of 4 is 2, and so then -2 to the 5th power, bring that negative over into your answer, -32. All right, we have -27 to the 2/3 power. This time the rational exponent applies to the whole quantity, so I can write that as the cube root of -27, and then I'm going to take that value and square it. So the cube root of -27 would be -3, and then I'm going to take that value and square it, and I get 9. All right, -100 to the 3/2 power. That means I'm going to take the square root of -100, which I cannot do, right? Whenever your root is even and you have a negative under your radical, you know that that is a non-real number. Okay. The meaning of a to the negative m over n. So really it's the same thing we've been doing. Only difference is now we have a negative exponent, and if you recall the rules for negative exponents, whenever you have a negative exponent, you flip it. So a to the negative m over n is equal to 1 over a to the m over n, or you can write that as 1 over the nth root of a to the m power. All right, so you want to evaluate each exponential. The first one is 16 to the -3/4 power. So first rewrite this as 1 over 16 to the +3/4 power, and that would be 1 over the 4th root of 16, and then you're going to take that value and cube it. All right, so we know that that would be 1 over 2 to the 3rd power, which is 1/8. Let's try another one. 25 to the -3/2 power. So first we're going to rewrite it as 1 over 25 to the +3/2 power. And that would be 1 over the square root of 25, and then you're going to take that value and cube it. So the square root of 25 is 5, so that would be 1 over 125. All right, let's try one more. It's 8 over 27 to the negative 2/3 power. All right, so first we're going to flip everything that's inside the parentheses. I'm going to make it 27 over 8, and now that is to the positive 2/3 power. All right, so that means you want to raise both your numerator and your denominator to the 2/3 power. So I can write that as, let's see, the the cube root of 27 over 8, and then whatever that is, I'm going to square it. So the cube root of 27 is 3, the cube root of 8 is 2, and then I'll square that and get 9 over 4. All right, I have this example here to show the difference between the two. So if I have 16 to the negative 1/4 power, that means I'm going to rewrite it as 1 over 16 to the 1/4 power. Whenever you have a negative exponent, you want to flip it so that it becomes a positive exponent. So this would be 1 over the 4th root of 16, and that would equal 1/2. Okay, so distinguish between that one and this one, where I'm not going to flip anything because my exponent is not negative. Okay, so this would equal negative 4th root of 16, which would equal negative 2. Okay, and notice that the negative goes outside of the radical because it's not in parentheses. The exponent only applies to what is immediately in front of it. Okay. All right, we want to write each exponential as a radical. So again, same thing that we've been doing. So 13 to the 1/2 power is the same as the square root of 13. And you can stop there unless it tells you to evaluate it to a certain decimal point. You can leave it in radical form. All right, 6 to the 3/4 power would be the 4th root of 6 to the 3rd power. All right, 9m to the 5/8 power. Again, remember that the exponent only applies to what's immediately in front of it. And since this 9m is not in parentheses, it only applies to the m. So that would be 9 times the 8th root of m to the 5th power. All right. Same type of example, 6x to the 2/3 power. 2/3 only applies to the x, so that would be 6 times the cube root of x to the 2nd power. All right, so here we have subtraction of two rational exponents. With the first one, the 2/3 only applies to the x. The other one, the 3/5, applies to the whole quantity. So I can write this as 6 times the cube root of x, and that is squared, minus the 5th root of 4x, and then that will be cubed. All right, and one more. All right, a squared plus b squared to the 1/2 power. Just remember this a squared plus b squared is a quantity. It's married, right? So that will equal the square root of a squared plus b squared. All right, example 5, write each radical as an exponential and simplify. So this time we're starting with a radical and we want to write it as an exponential. So of course this would be 10 to the 1/2 power. Okay, so just remember when we're doing this, roots are down low, so the root is your denominator and powers are up high, so the power is your numerator. So I would write this as 5 to the 4/2 power, but simplify it and make it 5 squared. And we know that 5 squared is 25. All right, the 4th root of 3 to the 8th power. Just remember the power is your numerator and the root is your denominator. So that would simplify to 3 squared, which is equal to 9. All right, the 6th root of z to the 6th, that would be z to the 6 over 6, which is just z.